So this is example 3 in lesson 4-7, where we're told that an airplane travels 2,050 miles in the same amount of time that a car travels 260 miles. And then we go on to say that the rate of the plane is 358 miles per hour greater than that of the car. So say we call the rate of the car R, then that means the rate of the plane is R plus 358 miles per hour, because it's got to be that many more. And so the question is, find the rate of each. And so we want to find the rate of the car and we want to find the rate of the plan. Well, this is an example of a rational equation that can be established using a rate time situation. We know that distance is equal to rate times time. Well, we clearly have our distances for both the plane and the car, and we know a little bit about our rate for both the plane and the car. The rate of the car is R, the rate of the plane is R plus 58. What we want to find is the time. We know that the times are equal. So what we can do, like we did in the previous example, is try to isolate the time in this basic distance equals rate times time equation, and then use the information provided in the stem of the problem to determine what those times are, and with the understanding that we remember that they are equal. So to solve this equation for time, we're going to need to divide both sides of the equal sign by rate. That will allow us to cancel our r's, and we'll have time alone. Time is equal to distance divided by rate. Now remember, the time here is the same as the time here. So the time that it takes the plane to go that far is the same as the time that it takes the car to go that far. What that basically means is we can take distance over rate, which is the time of the plane, and set it equal to distance over rate, which is the time of the car. Those have to be the same because their times are the same. So now if I do that, let's see, distance of the plane we were given was 2,050 miles. Rate of the plane, we didn't have a numerical value, but we do have an algebraic expression, R plus 358. That must equal the distance over rate for the car. So the distance of the car we were given was 260 miles. Rate of the car, the expression we determined was R. So now we want to solve this rational equation. The easiest way to do so is to cross multiply. Take what's on top of the first fraction times what's on bottom of the second, and set it equal to what's on top in the second fraction multiplied by the bottom of the first. And now it's just a matter of solving for r. Getting the r alone, it is a linear relationship, a linear equation. R is to the first power. It's not quadratic. R is not to the second power, so we just want to solve for r. We're going to subtract 260r from both sides to bring the r's together, to collect them all on one side. And by doing so, we will have 1,790r is equal to 93,080. And then, of course, r is being multiplied by 1,790, so the opposite of multiplying by 1,790 is to divide by 1,790. And when we do so, our 1,790s over here cancel, and we have r is equal to 52. So remember, r represented the rate or speed of the car. So the car must have been traveling at 52 miles per hour. The plane, we know, was going 358 miles per hour faster. Therefore, we have to find the rate of the plane by taking 52 plus 358. And in this case, we find that the rate of the plane is equal to 410 miles per hour.